Now, what will happen, the steps to recall when the co-repressor is present. When co-repressor is present, the first step, the regulator gene codes for inactive repressor protein. The regulator gene codes for inactive repressor protein, the same. Next, if the co-repressor tryptophan is present, it binds to the inactive repressor protein. Now, in this case, we have taken the possibility that co-repressor is already been formed by the metabolism. So, this co-repressor tryptophan will go and bind to the inactive repressor protein. Now, the binding of the co-repressor changes the shape of the allosteric repressor, that is, the inactive repressor protein, causing it to become activated. Now the repressor will be activated. Okay. Now the activated repressor protein binds to the operator region of the operon. When it is activated, when it is uh, active, in active condition, what it will do, it will ultimately remember that okay, now I have to do my job. So it will go and bind to the operator region. Now what happens? When the active repressor protein bound to the operator region, RNA polymerase, which is the enzyme which is responsible for the transcription of the genes, is unable to bind to the promoter region of the operon. This you know that once the space at the operator region has been occupied, the RNA polymerase cannot bind to the promoter region. Yes? Now, if RNA polymerase does not bind to the promoter region, the 5 genes coding for the enzymes in the tryptophan biosynthesis pathway are not transcribed into messenger RNA. Okay, when the space has been occupied, there will be no possibility for the RNA polymerase to bind, and finally the synthesis of these 5 enzymes given by 5 different genes which are responsible for the tryptophan synthesis will not be formed, and certainly tryptophan will not be formed inside the cell. Now, without the transcription of these 5 genes, the 5 enzymes needed for the bacterium to synthesize the amino acid tryptophan are not made, and hence no tryptophan is made. Clear? There will be no tryptophan formed. And what will happen when there will be no tryptophan formed? Tryptophan will not go and bind. Then it will finally be consumed inside the cell. Already present tryptophan will be consumed by the bacterium. And once the tryptophan has been consumed by the bacterium, so it will not go and bind to the inactive repressor or the allosteric aporepressor. So what will happen? Ultimately, the repressor will again become inactive and it will not go and bind to the operator. So RNA polymerase will go and bind to the promoter region, and then the transcription of the genes will be continued, forming the 5 different kinds of this tryptophan synthetase enzymes to be formed, and these enzymes are actually going and taking part in the biosynthesis of tryptophan. Clear? And once again the cycle will continue. What will happen? When the tryptophan is produced in excess, this is the line to be underlined. When the tryptophan is produced in excess, the cell is having surplus amount of tryptophan present. Enough amount of tryptophan is present in the cell. So no more synthesis of tryptophan is required actually. So this tryptophan will act as a co-repressor and will go and bind to the inactive repressor and will tell the inactive repressor that okay, I am here, no need to synthesize more of me. So it will go. So now it will become activated, the repressor will become activated, and it will finally go and bind to the operator region, and this will start the synthesis. This will stop the synthesis of the enzymes again. And this is how the cycle goes and goes and goes. Okay. Now here Last point to remember. Repressible operons are turned off in response to a metabolite, which is a small molecule which is undergoing metabolism, that regulates the operon. Okay, this whole system of repressible operon has been regulated by tryptophan in this case. So the example in TRP operon, in repressible operon, the example will be the TRP or tryptophan operon, where where the repression is being done in the presence of tryptophan itself. Okay, so this is the last point to understand here in the repressible operon system, that generally the repressible operon system is switched on, but it is only switched off in the presence of the metabolite itself. And in this case of TRP operon system, what is that secondary metabolite which is regulating the synthesis of itself? It is the tryptophan. Clear to all of you? So here we have completed both these systems, both these inducible and repressible system. Two small topics are left in this chapter. I will be continuing in the next class and we shall be finishing this chapter. Okay. Thank you so much. All the best.